Hello, this video discusses weathering, specifically chemical weathering. In a previous video, we discussed mechanical weathering and how weathering is different from erosion. This video is part of a series that coincide with the opengeology.org textbook that was developed at Salt Lake Community College. There's a link to it below the video. So in this video, we'll discuss chemical weathering, which is the chemical reactions that alter and break down rock and turn it into new compounds. A lot of times that's soil. Mechanical weathering has already done the hard work of breaking the rock down into smaller pieces, increasing the surface area in which chemical weathering can attack. And when chemical weathering is acting on a rock, typically the most important agent is water. You need water for effective chemical weathering. Water helps transport ions and molecules around, and it is the primary solvent. It is what you can dissolve a lot of different atoms into. The major types of chemical weathering that we'll be discussing is dissolution, oxidation, and hydrolysis, with the emphasis on dissolution. Here is the average annual precipitation in the United States, the continental United States. As you can see, there's a dramatic change from the East Coast to the West Coast, where the Pacific Northwest gets a considerable amount of precipitation, as does the area east of the 100th meridian, where you don't really need irrigation to water your crops. In these areas where you get large amounts of precipitation, that is also where you get large amounts of chemical weathering, as depicted in this water erosion vulnerability map released by the U.S. Department of Agriculture. One of the ways you can chemically weather is through the process of dissolution. And that's where you dissolve your minerals in water, creating free ions, charged atoms floating in the water. A great example is mixing salt crystals into water. I'm sure we've all done this, or with sugar as well. You dissolved salt or sugar in water. Halite, which is rock salt, sodium chloride, is one of the most water-soluble minerals. Other things that can dissolve readily, like pictured below, is this large hole from the dissolution of the mineral gypsum in the reef area. Natural carbonic acid in rainwater increases the dissolution of minerals like calcite. That carbon dioxide, the gas carbon dioxide, mixes with natural water to make the water slightly acidic. That slightly acidic water can dissolve calcite over geologic time. As it re-enters areas and releases the carbon dioxide, that water will precipitate or create mineralized stalactites and stalagmites in caves, tufa in springs, and travertine in other situations. So you get the dissolution of calcite and then the redeposition. And when you dissolve calcite, you create features that are known as karst. These are sinkholes, dolines, caves, and other things that are related to this dissolution of rock material over time. Here's a large sinkhole in Guatemala with the street for scale. Here in Utah, we have a number of ranges in the Basin and Range that are made up of limestone, which is made up of calcite, and that dissolves from this carbonic acid over time, and you can get these very, very deep cave systems as the water moves its way down to the base level, as depicted in this illustration. Some of the deepest caves in the U.S. are here in Utah, number 11 being Main Drain Cave, over 1,200 feet deep, vertical shafts. Neff's Canyon Cave, Brush Creek Cave, it's in the Uintas, Polygamy's Inn Cave, all fairly deep caves systems. If you dissolve enough material away, you can end up with features like these in China, known as tower karst. Another way to chemically weather something is to oxidize it. If you have free iron in your rock, it is especially susceptible to oxidation, creating a rust color. This is essentially what's happening in this car and this picture is the oxidation process. Oxygen combines with the iron, forming an oxide iron oxide, which is your rust. A lot of times, without water, this can be a relatively slow process. Water drastically increases this, as does salts in the water can help speed up the reaction as well. You get a lot of oxidation in marine type or coastal environments. Here is some of the oxidation of iron in terrestrial sandstone here in Utah. Hydrolysis, the important takeaway for this is the reaction of material with water, and this is most important with the breakdown of silicates becoming clay minerals, weathering into clay. And what you can see with this chemical changes, this weathering over time, is a weathering rind in rocks. The orange, more orangey coloration on the outside of the rock is the weathering rind, and the inside you see it's more gray. And that's why a lot of times geologists will bring a rock hammer with them and break open rocks to see a fresh, non-weathered surface in that rock. That's it for chemical weathering. Please do come back. We'll discuss sedimentary rocks and environments of deposition and other geologic interests. So thank you for listening, and I hope you learned some geology.